Let's review the idea of inverse functions. If f of x is equal to 2x, that means that f inverse of x is equal to x over 2. Now, you go through this long process to figure out what the inverse function f inverse is, and you'll end up with x over 2. But where did it come from? It came from the idea that, remember the steps that you do? You let y equal 2x, and then you solve for y, and then, you solve for x, and then you rename, you swap the x's and the y's, and then that's your f inverse. But they have this property when you do these steps, is that when you compose f inverse together, they're going to cancel each other out and just leave x. And when you compose f inverse with f, it's going to cancel out everything and just leave x. So what an inverse function does when it's composed with the original f function, it undoes everything that f does to the x and just leaves x untouched. All right, so that's just an example when our function is 2 times x, a very simple function. Now, what if f of x was more complicated? What if f of x was equal to base b raised to the x power? What would the inverse function do to this guy? Well, it's going to have to get rid of everything but x. It's going to take what f has done to x. Look what f has done to that poor x. It's put it up in the attic and made it the exponent on base b. Then f inverse will come in and take that x out of the attic and get rid of the b. So let me try to say this in a few different ways. F inverse has the job of basically undoing, it's going to undo, quote, taking base b raised to the exponent x. It's going to undo that. Taking base b to the exponent x. In other words, f inverse is going to isolate the exponent that base b is raised to. It's going to isolate the exponent that base b is raised to. In other words, f inverse is going to end up being the exponent that we raised base b to get the number, whatever the number was. Okay, now, let's swap the x's and the y's in this, just like we do when we're finding the inverse function. If we swap the x's and the y's, I want to put a name on this. You know, when I did the f inverse at the very top line of this video, I said f inverse of x equals this equation, x over 2. So x over 2 defined what f inverse did. Okay, so I need some way of saying my function is going to take the base b and expose just the exponent and all this garbage. Well, the way you say that, the inverse, is you call it a logarithm with the base b. So swapping the x's and the y's, I just want to come down to this final statement. In other words, y is equal to log base b of x. In other words, f inverse of x is equal to log base b of x. So y, which is a logarithm, is equal to the exponent that we raise base b to get the number x. Now remember, I swapped the x's and the y's, so don't get upset about me calling this guy x. Just try to absorb, if nothing else here, absorb what I just said. Let me put a big box around it. Y equals log base b is an exponent. What exponent is it? It is the exponent that we raise base b to get the number x. Log base b of the number x is the exponent that we raise base b to get the number x. And it is the inverse function of the exponential function.